Hello everyone. Uh, this is my topic for master thesis. Automatically annotating accessibility data to a terrain for a four-legged robot to pass from it. I'll start with a very basic example. Nowadays, the robots can move or do tasks by using a control system that commands the actuators and movers. We can motors, sorry, we can consider this control system as a gamepad or joystick which is controlled by us humans. This way we provide essential decision making to the robot, and it is not making decisions on its own, but we are the one who provide informations. In some cases there are possibilities that sensors are used to stop the collisions, but other than that we do not uh, put the robot into on its in its own control. Until this point we haven't done it, but uh, we can put a robot into a situation when it can sense the environment, and according to the past experiences it decides to do the task. I'll put two situations when we need it. One, which is space exploration. Second is when accurate decision making is required. Basically, both of these tasks are very similar. Let us consider first space exploration. A Mars rover is physically far away from us. If we send a decision making signal via electromagnetic waves, it takes around 12 um, minutes, and to reach there also we need sensor data to provide decision, which is why overall we need 24 minutes in a cycle to guide the rover. This is not practical basically. Another problem, combat condition or high precision decisions. In combat condition with high speed of incoming data for multiple decision making, we need to make accurate and multiple decisions because the decisions might have unfavorable causes. Therefore, we cannot rely only on human intervention during UAV in combat conditions. We can also consider the same situation for commercial flights in autopilot mode. Therefore, we need to give the robot the decision making. My problem task is very similar to the situation of commercial flights in autopilot mode. Let us consider a quadrant robot traveling through a terrain we do not have information about. In case of the terrain is not accessible enough, we can classify the worst situation for the robot in two classes. One, which is it might slip. Second, it might get in a situation when it cannot mobilize its legs. To make the robot decide in this situation, we need to create a ML or statistical model that, by observing the incoming sensor data, decides if this terrain is accessible or not. We will talk about how to create these models later, but first we'll talk about data. To get the robot's sensor data, we need the robot to traverse through terrains and generate data. Obviously, we do not want our robot to fall, therefore we need to create a simulated environment where we can simulate the robot's movements and generate data. For this, we'll use a physics-based simulation software, Gazebo. Gazebo also offers inbuilt sensors to simulate sensor data. That is what we need. So we'll use Gazebo in it. We'll also interact with the robot inside the Gazebo with the robotic operating system ROS. Now we have the data, and let us consider model, how to create a model. There are multiple possibilities in here to think about. We narrow down the possibilities by reading previous research on the same topic. First, let's consider the question. First question is which sensors to be used. camera or IMU? Naturally, we believe that camera should be a good way. However, camera can only see the surface of the terrain and it lacks information about the situation below the open surface. This is why researchers say that IMU is more accurate in this situation. Which models can we use? Second question is, which models can we use? We will primarily try to create an explainable data analysis with data that we get. However, this problem may need multiple dimensions and might not restrain to 3 dimensions. Therefore, we also have to use some unsupervised learning algorithms that might solve the problem. There are multiple unsupervised algorithms, but for our task we may use 3 of them: self-organizing maps, k-means clustering, and auto-encoding. I've listed the research paper at the end of this presentation. Let's conclude all this. Putting it very easily, we'll generate accessibility data of a terrain by using simulated robot, and we will generate IMU data. This data will then be used to create models with multiple algorithms, and then we can use the best performing generated model in the future to detect potential slip or immobilization. Thank you for your attention.